In this tutorial, we'll be building a simple web application in Java. We'll be using Tomcat as a servlet container, Derby as a database, and Eclipse. In this particular tutorial, we'll be building an online bookstore, but we'll be implementing many common web app features that you can use for your own app, such as creating pages using JSP and navigating between them, accessing and displaying information from a database with JDBC, user accounts, shopping carts, and more. Let's get started. Let's start by creating a new dynamic web project. We'll use the project name Bookstore and Tomcat 8 as the target runtime. We will do this by providing the directory we downloaded Tomcat into. Once we've done that, we can simply click Next as we have no source files. And make sure to allow Eclipse to generate our web.xml file. We can now try to run our web app by choosing Tomcat from the list of servers and making sure our web app is configured. However, as we have no content, we receive a 404 error. So, let's add a few pages. All our publicly accessible content goes in the web content folder. So let's create a JSP file called welcome.jsp. If you are new to JSP, imagine them as HTML files, but with some extra features. As you can see, the generated page looks just like a HTML file. So let's add a title and a body. We'll create a second page called mystuff.jsp. Then we'll make a link from welcome to mystuff. When we run the app, Eclipse will automatically open the page we're editing, as you can see in the address bar. And while the server is running, we can access the page locally from a web browser. But if we remove the welcome.jsp part of the URL, we get a 404 error. We have not set a default welcome page, but we can do this by editing the web.xml file. Let's set our welcome.jsp page as the sole entry. And now when we access our app from the web browser, it'll load welcome.jsp by default. Now we can begin adding some content to our page, say the catalogue of books for sale. Of course, if we want to be able to dynamically add and remove books, having it in static text like this is not going to be of much use. We want to keep this data in a data structure, perhaps inside a collection such as a linked list. We can easily create classes to do this, but there are certain conventions we should follow. Firstly, they should be serializable. They should have a zero-argument constructor, and they should allow access to their properties using getter and setter methods. Classes with these particular properties are called beans. Now that we've created a book bean, let's create a bean to hold all of these books, a library bean. We'll extend Java's linked list class, and we'll add a few entries into the constructor. But we won't need to add any properties on top of those that the linked list class already provides. Now let's go back to our mystuff.jsp file and delete that static text. Now we need a way to access our library bean. Fortunately, this is very easy to do. We can declare and instantiate any bean using JSP's useBean tag, just like we can when we write an ordinary Java program. The ID attribute corresponds to a variable name, and the class attribute is the variable's type. Now that we've instantiated the library, we can access our objects using Java's expression language. EL simplifies the way we access beans. For example, we can use array notation to access a list element, and we can access our bean properties more compactly. This would be easier if we could iterate through our list. We can embed logic into our markup using tags from the JSP standard tag library. Tomcat does not ship with JSTL built in, so you'll have to download the jar package and drop it into your lib folder. We must also include the tag library at the top of the markup so that we can use it within this JSP file. Now we can iterate through our library using the forEach tag. But before we move on, you might be wondering what exactly happens when we use the useBean tag. Now I explained earlier that it was similar to instantiating an object, and in this case, we've created an instance of the library class. But does this happen every time we load the web page? What if we had a function to add a book to the library? Would this new book still be there if I reload the web page? The scope attribute of the useBean tag allows you to specify the scope of the variable. If you don't specify a scope, then the object will be instantiated every time we load the page. And this means you'll get a new library object each time. And any changes we make to our library, like adding or removing books, won't persist. If we set the attribute to session, then our object will persist for the whole session. Now we can make changes to our library, but other users accessing this page will get their own libraries for their own session, and they won't see our changes. So we want to set this attribute to application, which means the object will be instantiated only once, until the web app is halted. To allow users to add their own books into our library, we'll first need to create a web form to collect this information from the user. Recall that the action attribute specifies how we're going to handle this form data. We'll do the processing on a separate page called add.jsp. So let's go ahead and create this file. When a user hits the submit button, they'll be sent to this page, add.jsp, with all the form data stored as request parameters. We can access these parameters using EL, just like this. In order to add the book to the library, we simply have to call a method in our library class that does this. We haven't actually written this method yet, so let's do this now. Now we can add books to our library. We can save the user from having to click the back button to go back to the listings page by using the JSP forward or include tags. These tags are similar, but include lets us add a short message for the user. You now have all the tools at your disposal to write almost any simple web application in Java. Although HTTP is a stateless protocol, keeping track of user sessions is incredibly easy in JSP. The complete web application can be implemented as seen in this diagram. A login page can be used to validate and instantiate the user session bean or to create a user account. A sell page can allow a user, if a user bean is instantiated, to create a new listing. A browse page can allow users and guests to browse and search the library. Each JSP page can also invoke a call to an event log bean to record each event, perhaps for archival purposes. And an admin page can allow a special user with admin privileges to view an event log. This design is fine for simple web applications, but as your application grows, you will notice a few things. Your beans will grow larger, become more complex, and become very application specific. Your JSP pages will start to accumulate a lot of control logic and invoke several beans. You'll probably create pages only to do some processing before forwarding to another page, without rendering any output. And you'll notice that having a separate JSP file for each view is neat and tidy, but only when you're expecting simple requests. You may want to intercept and filter certain requests. For example, you might want to allow admins to view pages in a different way, or perhaps you want to enable users to perform several actions at the same time. JSP files can be unmanageable in these situations, and JSP was certainly not designed for it. To address this, we can create a special class called a servlet. A servlet can directly respond to a HTTP request, allowing you to perform processing directly on the request in Java, then delegating actions to other servlets or JSP pages. It also allows you to encapsulate all control logic into your servlets, including the instantiation of beans, leaving your JSP pages only to render HTML. This can greatly simplify a complex design and makes it easier to reuse, test, extend, and refactor. And this kind of design is called the Model View Controller design pattern. When we create a servlet, we must also specify a URL that our servlet can be mapped to. Then we can handle GET and POST requests and perform any necessary processing using a command map. The use of a command map allows us to easily extend the functionality of our app and encapsulate it within a class. Finally, we can forward our request to a JSP page. Now let's demo our web app. When a user hits our page, the controller servlet intercepts this request. This is because I've set the welcome page to our servlet in our web.xml file. We then process the request in the doPost method. Then we'll look up the request string in our command map. Now it is a default request with no parameters, so I've mapped the null value to the index command. There is nothing to execute in this command. It just provides us with the name of the JSP file to forward to, in this case, index.jsp. Now I've secretly created pages called navbar.jsp and modal.jsp, and our controller will include these files before forwarding to index.jsp. Navbar.jsp will render a navigation bar at the top of the page, while modal will render pop-up boxes for user feedback. Now let's click the Browse tab in the navbar and see what happens. Now our servlet sees that we are performing a browse action. We see that browse is mapped to the browse command, which declares a bean called listings, sets an action attribute for the navbar, then sends us to browse.jsp. Our servlet then forwards to browse.jsp, which uses JSTL tags to loop through and render each listing as a thumbnail, and our navbar reports that we're on the browse page. Now you notice that the add to cart buttons are not active. We did this using simple JSTL logic. So let's register an account. In the same way, when we click register, our app executes the register command, which returns an empty form, register.jsp. After entering my data, hitting submit will simply refresh the page as I've not supplied a form action. However, the fields are now loaded as parameters and the command can check if we have valid data or not. If it does, we use the Java Mail API to send us an email and a confirmation code. This confirmation code gives us a link with the action confirm and a code which the confirm command can use to verify the account, sending us to the home page. But before forwarding us, it will set a modal attribute to display a message for the user. Now we may log in. This action simply retrieves a user bean, to which our user variable is then assigned to. Now that we're logged in, we can add a book to our cart. The cart object in our user record is first updated with the new listing, and then is given to cart.jsp, which renders the listings within our cart. Similarly, we can add a new book to the library. In this case, I've consolidated all the possible form fields into one file, cell.jsp, and the controller servlet can choose which ones to display, depending on what stage of the book registration we're up to. Finally, our controller validates the data, updates the library, and presents some user feedback. Our user can log out. This action simply sets the user variable to null, which represents a guest user in our case. And finally, when we log in as the admin user, our controller will also include admin.jsp, which will append admin functions to all our pages and also the navbar. Some admin functions I've implemented are event logs, an interface to view and ban users, and so on. Building new features simply becomes a programming exercise, which I'll leave to you once you understand how states can be maintained in a stateless protocol. Now you may be wondering, what if I want my data to persist after I restart my web app? You also might be wondering why I didn't demonstrate the search functionality. You may have thought of ways to address these problems yourself, but it's a good idea to delegate these tasks to database software. Databases are highly optimized for storing, managing, and searching large amounts of data, and it's a good idea to learn how we can utilize a database in our web application. In our application, we'll use Derby. The setup process for Derby varies between platforms, and Derby can be run in different modes: embedded or network mode, with larger, more complex projects preferring the latter. Once you've set up Derby in your preferred mode, we can easily integrate it into our web app. Because we have encapsulated all our library and user data into our model layer, we can easily modify this layer to make calls to our database, and our control layer does not need to know about this change. We can easily do this by deleting our instance variables in our user, users, book, and library classes, where this data is currently stored. And then replacing our getter and setter methods with calls to our database using JDBC. When we do this, we can refer to these objects as data access objects, a term signifying that it's an abstract interface to some database. The only problem with this is, we'll be making a database call each time we access any field of our record. This might be fine for your application, where access to these fields don't happen that frequently. But in a large web application, we may want to reduce the number of times we invoke the database, because sometimes these calls can be time expensive. So for now, let's revert our user and book classes. Instead, When we need to access a particular user record, our users object can return this record as a single user object. When we strip away all our special business logic from the user and book classes, we can refer to them as data transfer objects. You can significantly speed up the design of your web app using a framework such as Bootstrap by simply linking the Bootstrap CSS files at the top of your own JSP files. You can access a huge library of customizable HTML components and controls, as well as different color schemes and themes. I hope you found this demonstration helpful.